Okay, here's the second part of the assignment for the map assignment. When you look at the downloaded files, you'll have another unit test file. You'll have some jar files, typical unit test ones, plus there's an additional one that you'll use for the assignment. Directions, there's a README file, and then there's a tree class. So if we look at the directions, what's saying with this one, you're going to implement a binary search tree using the directed graph implementation from the previous week. However, the directed graph and element class that you're going to use are actually in the provided jar file. So you're not going to use the ones that you created last week. You're going to create and use one that I provided. I believe it to be 100% correct it passes the unit test with what I'll be asking. So I believe it to be a good implementation of it. Certainly there could be bugs in it, but just with any code. But so you're going to use these two classes. You will not use your own. The only thing you're going to create is a BST class. This accounts for 30 points out of the total 100 for the program. So the first part was 30, this part's 30, and the last part, which will be next week's, is the remaining 40. What you're going to do is create a class called BST. The BST class will extend the tree class. So if we look at the tree class, see that it's abstract, so it provides some things. It provides some instance variables. In my implementation, these were the only instance variables I used. You can use other ones, but these are the ones that for the solution that I came up with. This was all I needed. You're going to provide and so then there's descriptions for each one, but you're only going to provide a couple methods. You're going to do one called getRoot. That's where you return the root of the binary search tree if there's one present. If it's empty, you return null, and it's going to be the element type with the key and the value. You're also going to have it where you add a element to the appropriate spot in the BST tree. So with this, you just call add on it. Then your code actually uses the directed graph to make sure that it updates the state of the directed graph correctly so it resembles a binary search tree. So this is the main part of this assignment that's challenging, and we'll talk a little bit about strategies, but getRoot should be pretty straightforward for you. Add element, I expect will be a little bit more challenging. Once you have your add element and you have that working, the find should be relatively straightforward. And the last thing you're going to do is you're going to have it where you'll print out the tree in post order only. So these are the only methods that you'll be tested on with the unit test. If you look at the README file, it has the two the publicly available methods, constructors, and instance variables that are present for the directed graph and the element class. These are identical to what you did in the previous week, so if you have any questions on these, you can just kind of look at the interface from the previous week and the directions, and that will give you a little bit more information about what specifically these are. But in your implementation, what you're doing is you're creating a directed graph. You're going to implement the binary search tree using this directed graph, and this is the different ways that you have to interact with that directed graph. So these are your public ways of accessing it. Same with element, it's the same deal. You have the two public instance variables, key and value. You have a constructor that just takes a key and a value pair, and you have the toString method and equals. So you don't have to worry about. They're provided in the jar. You just have to use them. So now looking at the unit tests, this shows you basically what the setup is. You have a BST declare. It has you declare what type what types of data it will take. So the first one is your key value, and the second one is your value. So for example, this takes strings as keys and integers as values. And this is the syntax for creating a new BST. This is the only constructor that you'll need to implement in your BST class, one with no parameters. This is showing adding a new element. And this would be one unit test. That's a simple one that just says, okay, I add one element to it, so that one should be the root. This one's a little bit more involved. It adds several elements to the BST tree. Your BST tree behind the scenes should put it together correctly. Then it tests to make sure that you have what you say is the root is what the root is based on this. Find, you'll have some different ones where you have to just you'll have a something to search for. So for example, in this one, it's a simple one. There's only one element in it. You go through, you look for cat, and if you look at the spec, whenever it finds a key, it's supposed to return the associated value, which in this case is 10. So it will return 10. So this is saying we expect 10. Does our method return 10? If it does, then it passes the test. This one's a little bit more involved. Again, this involves searching for something that should be in the binary search tree. This one involves searching one. Find two involves searching something where you've had you have the same key, but it gets overwritten. So in this case, even though there's ferns in there twice, it should return whatever the last one is. So in this case, 10. Should also, if there isn't something present in the search tree, it should return to null. And then just, this is the toString method. And so this right here, these strings show the format for that your post order to string method should print out in. So if you're confused about what it should look like, all this is calling the element toString and just concatenating them together. So it's actually pretty straightforward. So you'll implement the BST tree. I gave you the signature, or how you should start up the class file. Again, it's kind of like the other one. It's a little bit funky, and I expect you to know that. But what it's showing is that this is a binary search tree that will take generics, a generic key, and a generic value, and that extends a tree class, the provided tree class. So if you're using Dr. Java, you're going to have to add the directed graph.jar file there. And so you've had to do that with the CS416 file and other ones. If you don't remember how you did that, this link here provides directions generically on how to do that. It's pretty straightforward. If you're using Eclipse or another IDE, that's fine, but it's up to you to figure out how to get the jar file added to your project. So you're going to create a constructor that does not take any parameters. That's it. Other than that, you're going to implement the abstract methods in the tree class, and then you just finish off by running the provided unit tests. I'm only giving you one set of unit tests. If you pass them all, then you're guaranteed at least a 24 out of 30 or an 80 on the assignment. Failure to submit the correct file, which in this case is just bst.java, will be a fail, a 0. And also if it doesn't compile, it's also a fail, a 0. Restriction is you're only to use the element and directed graph classes provided in the jar file. You're not to use anything else. So that's what you got to use to implement this. So you'll have to do a little bit of thinking to figure out how to do this. I'll give you a couple tips in the next video. But on this, you're going to submit just bst.java. Do not submit bst.class. Some of you still get confused on the class file. Do not submit class files.